So let's have example number 3. The deflection at the free end. Determine the deflection at the free end. So what we're gonna do first is estimate the deflection at the free end with this with drawing the elastic curve. So maybe exaggerated rasad kayo. Anyway, I'll erase this for a while, change it a bit. Something like this one. So maybe and then just to be exact lang, okay, so this is the portion where deflection is asked. So this is the deflection at the free end. Okay, so no irregularities of the section, so only the loads are going to be considered. This is point A, this is B, and this is C. We have a resultant here. This is 45. And the vertical reaction here is 45. Summation of forces vertical. And then this one, MA. Actually, MA is equal to 45 times 1/3 of 3. It's 1 plus 2, so that's 3. So MA is 135. Next thing that we're gonna do is introduce a segment. So we're gonna cut this portion and consider the right side. So let's have segment AB. So I actually had segment AB already. So now let's get the moment equation. So M equal to 45 negative times x plus 1/3 of 3. It's 1. So that's our moment equation. Next is for segment BC. For BC, we're going to cut through here. So let's cut that portion. This portion. Here. So I'll copy that. And then I'll just delete some portion. And it should not be like this. So this is the point of cutting. And by the way, this is no longer equal to 45 since this is no longer equal to 3 because this is x now, and provide the moment equation M, and then I'll call this as y. So with that, we're gonna get the value of our y, and it's by ratio and proportion. So let's just move this around here. So ratio and proportion, it's y over x equal to, this one is 30 kilonewtons per meter, so it's 30 over 3. So y is 10x. And then we're gonna get the resultant. The resultant here is 1/2 of y times x. So the resultant is 1/2 of 10x times x. So this is 5x squared. Okay, we are now going to get the equation. Summation of moment at the point of cutting equal to 0. We'll have clockwise M, and then equal to negative 5x squared times 1/3 of x. So M is negative 5x cubed over 3. That is the equation. Next that we're gonna do is we're going to draw now I forgot the vertical beam. So this is the vertical beam. Can I not erase na lang this one and just copy this? Copy and then paste it here. Then I'll just remove this portion since this is not X yet, and this is 2 meters, and this is a fix. Also, since this is a vertical beam, we're going to erase all the loads. And since deflection at the free end is asked, place the 1 unit, and then the direction is from this position towards here, it's downward. So that's our assumption. And with that, we can get now, by the way, this is point A. We can now have a different value of A vertical. This is 1. And then our moment A here, MA prime. Let's solve the moment MA prime. Summation of moment A prime about point A equal to 0. You have MA prime equal to 1 times 5. So MA prime is equal to 5. Next is we're going to now proceed in getting the segment. Segment AB. The same thing, we're going to cut AB and consider the right side. So cutting through AB, I'll just use this and paste it here. I'll remove this and that. Then I'll adjust this one. And this distance here from the point of cutting towards point B, this is now X, and this is small letter m. So summation of moment equal to 0, you will have m equal to negative 1 times x plus 30. Next, let's proceed with the segment BC. So we're going to cut through BC, and this is BC, by the way. Just copy this one. I just realized na pwede rin dito mag-copy here, then remove this. And transfer here. Also, do not forget the 1 unit is placed at point C. The 1 unit. Okay, so get now the summation of small letter m equal to 0. This is small letter m. And you'll have m equal to negative 1 times x, or m equal to negative x. Okay, the next thing that we're gonna do is get the deflection, and that is the integral of m times m dx over ei from a to b, and the limit is 0 to 2. Then plus the integral of m times m dx over ei, and this is from b to c. This is 0 to 3, and our assumption for the deflection is downward. Okay, so let us rewrite now the equation. So integral limits from 0 to 2. So what is the equation? Negative 45 times x plus 1. So it's negative 45 times x plus 1, close it, times negative 1 times x plus 3. I'm actually looking at this one, since that is the moment equation for AB. So this is over EI. then plus the integral of the next equation is, so limits is from 0 to 3. Next equation is negative 5 over 3x cubed times negative x dx over EI. So remember that we are having a product of both negative signs, so we can cancel that out for that term and this term also. So we now have the deflection here. So the deflection is over EI, and plus for the other one over EI, and this is downward. Okay, so this is our integral of 45 times x plus 1, close it, times 1 times x plus 3, close it, to 0 to 1, 0 to 2. So this is 70 or 750, excuse me. And then the next integral is 5 over 3 with x cubed, close it, times x. The limits from 0 to 3. This is 81. And the integral is equal to 750 plus 81 is 831 over EI. This is kilonewtons cubic meter. And we obtain a positive value because our direction, our assumption na downward deflection is correct. Which is somehow correct man gyud kay cantilever man to. So this is now the deflection at the free end. So let me have again in my physical calculator. So yeah, have 45 times x plus 1 times x plus 30 from 0 to 2 ang limits. So it's 750 times or plus the integral of 5 over 30 x cubed, close it, times x from 0 to 3. It's 81. So 750 plus 81 is 831. All right, that ends our